Do you know what I want to do after a long day of coding Python in my day job? I want to hop onto YouTube and I want to code more Python, okay? Welcome to The Farmer Was Replaced. This is a brilliant, brilliant little incremental idle coding game where we are controlling this little drone here on the right to farm plots of land and get us resources to farm more plots of land, to get us resources to unlock more types of resources, and to basically build a coding empire, coding farming empire. It's a brilliant little game, and I wanted to come back to it because it's the 1.0 release of The Farmer Was Replaced. And when I came into my old save, every single bit of my code was broken because they have overhauled a lot of the game from the ground up. They've added achievements, they've added some different challenges, and I want to hop in and play a little bit more Farmer Was Replaced, okay? So we're here today in a brand new save, and I'm going to be kind of stupid today because what you should do is you should make the most efficient code that you possibly can in this game. And instead, I am going to make really inefficient code in this game that hopefully looks cool. Alright? Let's get started, and you'll see what I mean. So if you don't know how to code Python, you'll pick up a little bit from this video, but the nice part is that this game actually teaches you how to code Python. So you can use this as a bit of a educational experience and get yourself some knowledge of how to code. We can start by calling this harvest function, and that will tell our drone to harvest what it is underneath. So I can start to harvest this wheat here, and we are generating some nice solid hay up here in the top. I guess it's grass, not wheat. Now that I have some grass, I can come into my tech tree that has a whole bunch of stuff for us to unlock, both mechanics in the game, but also types of coding operators and variable types and things that we would need to create some interesting ideas within the game. The very first thing that we can unlock is a simple while loop, which is going to be very useful because we can set up a loop for our harvesting, and we can say that while true, we will harvest. So this is always going to be true because this says true. So while it's true, harvest. And it's just going to infinitely harvest our hay without me pressing the button to do so. If this doesn't make sense, you could do something like while 1 equals 1, right? Because 1's always going to equal 1, and you're going to harvest. If we were to change this to 2 equals 1, well, it doesn't do anything because 2 does not equal 1, so we never go into our loop. So while that is harvesting, let's take a look at our tech tree. We got more things that we can do. We can increase the yield of grass. So instead of being at 100%, we could go to 200% and basically get double the amount of value out of harvesting grass. That sounds cool, but I need 300 hay to get there. And while we'll get there in a little bit, I don't feel the need to go too crazy right now. What I do want to do is increase the speed of both the drone and our code execution. So let's do this. Our execution speed has now doubled, but as you can see here, the problem is that if the drone now harvests faster than the grass can grow, we don't get anything. So now we have some new logic that we can bring in, and that is the can harvest function. And we can basically say, hey, if you can harvest, then harvest. And this guy is now going to get back to doing some nice, brilliant work here. And if you need to know more about what can harvest can do, it's going to return a true or a false. So if this returns true, then if true, we harvest. If it returns false, well, we're not going to harvest because this is a false statement. So he's just going, he's having a good time. And we can start to think about unlocking even more stuff, such as hats. Okay, a hat for my drone. It costs 50 hay to do it. You're probably like, Tyler, this is not worth it right now. I disagree, okay? I disagree. I want to change my hat. And this is where you're going to see something very, very exciting. Because instead of getting a gray hat, I'm going to grab the Olexa's hood hat. Because the developers have been so very kind to reach out to me and offer me my own hat in the game where it turns the drone into me. And I think that is the coolest thing on planet Earth. Massive thank you to the developers for giving me this little toy to play with today. I absolutely adore it. So thank you very much. Now that we have our hat, let's get back to harvesting, and we will take a look at some more upgrades. We can expand our farm and unlock movement, which I think is very good. We can also unlock bushes, which allows us to plant bushes, and we can start to get wood. Let's do that, and then let's come back and let's expand as well. We got a lot of text on the screen here. We've got bushes, we've got expansion, we've got all kinds of things. Just let your boy Tyler teach you what's going on here. So our farmland has expanded, which is very nice. We're going to pause your execution for right now, and we're going to start planting bushes, okay? So while 1 equals 1, let's plant a entity dot bush. If I can type correctly, we'll get this in. But we don't necessarily want to just do this, right? We want to eventually try to harvest this bush. So let's throw in a if you can harvest, harvest. And now he will harvest, and then he will plant that bush, and then he will harvest, and then he will plant that bush. But, I mean, come on. While he's waiting forever, man, we would really like him to do some more things while he is planting that bush. So let's send him on a little journey, okay? We're going to move our drone north, and then we're going to try this again. So now you're going to start planting, and you're going to just scan. You're going to scan till it's ready, and then you're gonna pluck it out, and you're going to scan till it's ready. You're going to pluck them out, and all of a sudden, we're starting to produce a little bit. And I think it's pretty cool. Now, once you harvest, by default, he's just going to throw hay back into that spot. So we could even throw like a little after the harvest, plant the bush again, okay? And I think that's a nice way for us to get some halfway decent stuff here. And that way we're getting a good chunk of wood. So taking a look at our other stuff, we can expand the farm again to a 3x3, which does sound kind of fun, so let's do that. We now also have introduced the for loop into play, as well as the function get world size, which is now available. And we have some interesting little code here that will allow us to start traversing our world a little bit better. We'll mess with that momentarily. We also have carrots that we are going to unlock momentarily, which allows us to till soil and plant carrots. And I need those carrots in order to do, like, literally everything else in the game. I need to get down to this print statement. I need to get these operators. I need to get these senses, and I need to get these lists. And then I can build what I think will look really cool and be the stupidest thing that I could possibly build in this game. So, you're doing fine. Let's unlock carrots, which is exciting. We can change the ground to grounds.soil by simply tilling the soil here. Planting carrots costs both wood and hay, which is very scary, okay? Because we're going to be losing resources to make our carrots actually happen. So let's build some new code, okay? Because right now, I mean, we have so much land, and this guy's just wasting his time doing this. So we want to get him traversing the entire grid. And how are we going to do that? We're going to do that with some for loops. So we want to say for x in get world size. And we're actually going to say in range get world size. Because how this is going to kind of work is we're going to loop through the range of get world size. So get world size is going to be the value 3 here, because our world size is a 3x3. So it takes the length of a side, which is 3, and it's going to say for x in range 3. And then we're going to say move north, okay? And we're going to let this guy scan to the bottom left. Come on. Let's move you manually to the bottom left. And then we're going to see how this works. So, for x in range, get world size, move north. You're going to come into Come on. Don't. No, no, no. I would like you to stop executing, brother. I need you to stop fully. Let's move you manually back down. We're gonna move you south. I don't have the ability to create my code to move him to the bottom left yet, but we will soon. We will soon. So let's step through and see exactly how this goes. 4x in range, get world size. So you're gonna come in. You're going to move north. You're going to come in. You're gonna move north. You're gonna come in. You're gonna move north. You're gonna come in, and you're gonna stop. Okay? It's beautiful. It's exactly what we want to see. So now we can say for X in range, get world size. Let's move east. This is going to do the exact same thing, but instead it's going to go north and then it's going to go east, which is cool, but it's not really what we want here, right? We would much rather kind of go all the way up, move, all the way up, move, all the way up, move, circle back, and then keep doing it. So how are we going to do that? That's a good question. We're going to just kind of manipulate how we're building this, right? If I move this bit up here now, we can now kind of say, hey, 4x in range, get world size. Let's start by moving east once. Then we're going to scan, do all the north. Then it's going to loop back and it's going to go east, scan all. And you're just going to now scan the entire grid, okay? And I think it's very, very good. It's very, very good. Now we want him to also do this forever, right? So let's throw in our while true, and then let's also throw in our if can harvest, plant some bushes, okay? Because we want you to be really harvesting and getting some good stuff going. So now we can see that our happy drone is doing some nice scanning, and he's producing a good amount of wood. He's very happy, and we're now keeping up with our operations a little bit. Is it the fastest that I've ever seen this be done? No. I mean, realistically, we could have him, when he's up here, move to the right and then go down because we're wasting time with him circling back around to get to the bottom. But I just need resources right now, and I'm not too concerned. We'll speed him up. It's going to start to produce a little bit faster than before. I mean, you can see this lad is significantly faster than he was previously. And we can start to think about maybe bringing some carrots into the fray. So let's call this our wood script right now. And then let's make a new script. And this one is going to be for carrots. So how are we going to do carrots? We're going to say till now. And instead of planting entities.bush, we're going to do entities.carrot. All right. And then we're going to do this. And we're going to say entities.carrot. And now we can start to roll in and start tilling some ground here. Now, this is definitely not correct because we want to plant the carrots before we can check can harvest. So let's put this here, and then we'll put this here. And that should now give us carrots starting to be planted. It looks a little messy because we're pausing this guy in the middle of his operations. So it's a bit peculiar right now. I'm also realizing that he is not actually ever harvesting. So that is that's a problem too. Let's rethink the way that we're gonna do this, alright? Oh, hey, dude, call clear to reset the farm to all grass and reset the drone position. That's kind of nice. Okay. Let's start with a clear then. Nice. I like that a lot. So now, yeah, you're not doing exactly what we want to. Let's rethink this approach. So you're going to come in, you're going to move, you're going to till, you're going to plant some carrots. Then you're going to move north, you're going to till, you're going to move north, you're going to till, you're going to come down to here, and then you're going to till again, which we don't necessarily like. So let's take a look at our carrots, man, because I think there's probably a function that we can start to utilize here, which is potentially grounds.soil. But we need to be able to see the ground first, which would need senses to understand, I think, where we are. So let's do this. Let's do this a little bit differently then, and just start to harvest. So if we I mean, you can't really do a if can harvest at that point. We're a little too fast, my friends. We're a little too fast. Let's see what else we can do. We can. Yeah, it's really just the tilling, but we don't want you to do that. Let's switch this to a get world size -1. And the idea here is that now he will well, he's still gonna friggin' do it. Those carrots take so long to come in, man. It's very annoying. Okay, generate wood while we figure this out. Because those carrots they slow as hell. Fortunately, we actually are now getting a couple of carrots in here. But they are very slow lads. Why are you not planting in the bottom here? It's because... Why are you not planting in the bottom there? Okay, we're all kinds of messed up because you can never can harvest, so you never plant. Okay, yeah, that's a good point. It has to like get into the groove of planting and harvesting, right? I think the ideal scenario would be we till the entire ground and then we plant. Okay, so let's do that. Let's till everything, and then we're going to. We don't even need the wild true at that point. Let's do. It's kind of like farming in real life, right? You gotta till all the land before you go in and you plant. Then we can set up the wild true and kind of say the exact same thing here. But we're going to go with our if can harvest. Well, you're going to... I guess you could till and plant here. Entities dot carrot. And an entities dot carrot. And then we can come down here and we can say our if can harvest. Because I have a feeling that we're going to maintain that tilled soil. If not, then that's a little annoying, but we can work with it. So you come into here like so. And then let's keep that clear. Fortunately, we've now gained 260 wood, but this should be okay. Because now you're going to come in, you're going to plant. Everything's going to get nice and tilled. And then you're going to start to scan. And as soon as there's carrots to be harvested, you're going to harvest those carrots. And then this looks pretty good, man. This looks pretty good. So now with our carrots coming in, we can unlock some new things. Such as expanding the farm again. Which, I mean, I do think that that's a good idea. So let's do it. Okay, let's do it. Now we have ourselves a 4x4 in here. Now, this lad is just getting wheat right now, which I do think is still valuable. I mean, we do need wheat, all things considered. We should get debugging so that we can print and see what's going on in our code. I would like to increase the speed of our drone at some point, but that's a little ways away before we can get that much juice to get him going. So let me explain to you what my cockamamie idea is for today. Instead of just going in a very systematic pattern here, I want to build something much stupider, okay? I want to get this drone to spiral around the grid to here and then spiral back. And I think that it would look really cool while being literally so I mean, it's not even that inefficient, I guess, but I think it would be fun. I think it would be fun. And it's a fun little coding challenge that will we'll put on ourselves here to get figured out. So we're going to start coding that shortly. I think what I would like to do is, what do we need here? We need, I mean, we're going to get this right now. Let's get some logical operators. We're going to need those. We now need 100 hay to get senses. And I think that this is fairly important because now we can see what position we're at when we are in our code. So I can say get our X position, get our Y position, get certain things. So let's do that as well. And then the next most important one is this, which is going to be a little tricky. I need 35 carrots to get variables, and then I need 500 carrots to unlock lists. But I really think that lists would be valuable for us. So I'm going to pause. I'm going to collect a bunch of resources so that we can unlock all the things, and then I'll be back when we have more juice. I'll see you in a second. Okay, long time lapse of collecting resources later, and we have ourselves all of the things we need to now get started on our death spiral that we want to make. We've got senses, which is cool. This allows me to see what is under the drone, so we can get the position, and then things like number of items, things like that. We can now assign values to variables, which is exciting. But the most important, we've got lists right here. Two-dimensional arrays in Python, and we have functions that allow us to define our own functions. So I've defined one function for ourselves, which is the reset function, allowing me to basically get this guy back to 0, 0. So if we're running something like our hay, and he's up here in the middle of, well, let's run him to here. If he's, say, on this spot right here and we wanted to reset him back, we can now call this file. So this file is currently F2. We could call it, let's keep it F2 to be honest. We can import in F2 and then we can call F2.reset. And now he will navigate back to 0, 0. Just very simple loop. While the position is not 0, move east, and while the position is not 0, move north in the X and the Y. So he'll always get back to here no matter what. It's a good way for us to start since our spiral is going to be going counterclockwise around this. So again, the goal, starting here, spiral around our board to the middle, and then spiral all the way back. Why? Because I can, okay? Because it's fun. So what do we need in order to do a spiral? Well, there's going to be some kind of track, right? Some way for us to know when to stop each of these movements. So there's basically going to be a stopper in the south, the north, the east, and the west. So let's call it, we've got top, we've got bottom, we've got right, and we've got left, okay? And we need to know what the stopper for each of those is. So I think to start, we're going to need to have our world size. Let's grab that. Because our stopper for the top is basically our size minus 1. And in that case, let's just do get world size minus 1, and then we'll just say that top is equal to size. Right is also going to be equal to size because it's the distance going to the right. And then bottom and left are going to be 0 because that's effectively the bottom is the 0 position and the left is the 0 position for the Y axis. So what do we do now? I mean, now we basically move this sucker. So while our X position is not equal to, or we can even say it's less than, while this is less than right, we want to move right, right? So now if we play this, we should see him move all the way to here because our X position on this square is 3, we can see. And right now size is equal to 3. So while our X is less than right, move there. Once it hits here, it should stop. Okay, beautiful. Then we're going to do the same in the upward direction. So while get position Y is less than top, we are going to move north. And then realistically, you're going to reset, and now you're going to go north. And we will keep this for pretty much everything while get position X is greater than left, because now we're moving in the opposite direction. We're going to move west. And then while get position Y is greater than bottom, we are going to move south. So now, theoretically, if I were to set this up in a loop, he is just going to move in a circle forever. Which I kind of like, okay? I think that alone is pretty cool. But it is not doing the spiral that I'm looking for. So how do we achieve proper spiral at this point? Well, when he gets to this square right here, we need him to stop instead of going all the way down. So to do that, we need to increase the bottom value by 1 after we're done with being on the bottom, right? So when he moves right, after he's done moving right, we're going to increase bottom by 1. Then that remains the same, because now if we run this, so bottom would be there, and now he would start going this way because it loops back around, but he stopped right here. But now we have the same issue, right? Because now right is actually too far because we need him to stop here instead. So now we need to decrease right by 1 when we go up. Is this making any sense? Because I'm not sure it's making sense in my own brain. Let's decrease right by 1. It's basically after we move adjacent to a direction, we decrease the previous. So as we're moving along the bottom to go right, we increase bottom. While we're moving along the top next to right, we then decrease right. When we're moving left, we're going to decrease top. Top minus equals 1. And then when we're moving across the bottom, we're hugging the left wall, so we're going to increase left. And now, theoretically, he might just spiral. We might need to stop him when he hits this square, but he might just spiral, man. It's actually so good. That is so cool. Okay. So he has effectively spiraled, which is sick. And I think that we'll now set up we want some kind of flag to stop the spiral. I don't want to hard code it, because we could do something like while get position X is not equal to, this position is 1, 2. So while this is not equal to 1 and get position Y is not equal to 2, do all this. So now the code will actually stop when it gets to that point. And it would come down, to down here. But I'm not sure that that's actually what I want to do, because then we have to hard code this value, and if I increase the size of the farm, then the spiral is not going to work anymore unless I change these values. It is a manual step that I suppose in the grand scheme of things, it's probably fine for us to do that. Now, we have to get him to spiral back at the end. That was also part of the agreement. So we could go in and reverse all of this, but I have a cooler idea that I think that y'all are going to like. And that's the idea of just keeping track of our moves, okay? So every time we move east, we are going to append to the moves list west. Every time we move north, we are going to append south. Every time we move west, we're going to append east. And every time we move south, we're going to append north. Now, you may be like, Tyler, why in the world are we doing it like that? That doesn't make a lot of sense, because that's not the move that you did. And you are correct, my friend. You're correct. But what it allows us to do now is we can reverse our moves. So reverse moves is going to be moves reversed, which I believe this is a way to reverse a list in Python. So this should now work. And then we can basically just loop through this. So for each, we'll call it M. For M in moves, move M. So theoretically what should happen, this guy should spiral all the way to here. And then I actually, we're going to have him do a flip right here, because I think that's a cool way to indicate he's finished. And then we're going to reverse the moves, and he's going to do all the moves back in the opposite direction. So you spiral, you get to here, you do a backflip. Okay, you did not do that correctly. That's fine. let's look at what we did here. Is this how we reverse a list? I think so. Oh, I'm doing the moves, not the reverse moves. Sorry. Let's do reverse moves. So now you're going to skirt around, do a backflip, and then you're gonna go right back. Okay, dude, it's so cool. It's so cool. So that's our happy little death spiral, and I'm a big fan of it. We now need to get this guy to harvest and plant along the way, right? So let's just throw in, we have our stuff over here. I did make this change while I was farming for resources. Just a simple if-else over here. If you can harvest, harvest and plant. Otherwise, just plant. And that becomes a pretty nice way to handle this. And then we can even consider adding another variable into this, which would be what plant we want to plant, right? So we can say like, we'll make this entities.grass now. And then we can instead of always planting here, I can just say, hey, plant whatever plant we specify at the top. And then now we could theoretically call this as a function in something else to have it just roll through and plant a lot of things. So now we should watch. What's your issue? You tried to call something that's not a function. Is plant not a function? Really? If you can harvest, harvest. Really? I guess, oh, you're I understand. Because the variable is the same name as that. We'll just call it plant1. And that way you plant 1. That's fine. And then I guess we also want to, when you're reversing, we want you to reverse on through here as well. And that will work out just fine and dandy for me. There we go. And now we're back in business, and he's doing his proper spiral, doing a flip, and then making his way back. Dude, I love it. I absolutely love it. I think that is very, very cool. And then we can just throw this entire thing in a loop and run it forever. What's our next expansion for this? I need 50 carrots. Okay, well, let's do that. Okay, let's do an entities.carrot. And we'll let this guy run through. We're not tilling. Yeah, that's a pretty good point. Let's build something real quick to till. This should be fairly straightforward. I mean, to be fair, we can actually just run. Let's just run the carrot code so that we till all of the land here. And then now we can run this guy to get it back to here. And then our carrots are growing. He flips. Now, it's a little bit wonky because the carrots take much longer to grow, but I think it's fine. Okay. So now let's expand the farm. And now you're a 6x6. And this is how I want to really test if this is working. And I think it's going to be cool. Let's do entities.bush. And let's see if our spiral still works dynamically. This is going to be screwed up now, though. It does look super sick, though. He's going to stop here in a second, though. Yeah, because this is no longer the right spot. So the right spot will be spiraling around to here. So 2-3 is actually our new position. And then he can go back and do some more. Is it silly? Yeah, it's extremely silly. But is it fun? Yeah, it's really fun. So I don't really care. It's not efficient, really at all. And it's a complete waste of all of our time. But did I have fun doing it? I sure did. And that's the point of video games. So that's going to do it for Farmer Was Replaced. Massive, massive thank you to the developer again for putting in my hat, which since I closed the game, I no longer have on. And I should put back on here. We're going to do a nice little change hat. And Olexa hats, please. Hats, Olexa's hood. And then you know what? We're going to slap this entire thing in a while true. And let her rip. And send it. And now we have the proper Olexa Spiral of Doom is what we'll call it. Just brilliant. I absolutely adore this. I really do. It's so silly. And as we continue to scale up the farm to be absolutely huge, this will continue to stupidly be able to be used. And all we have to do is update this, which I still think there's probably an easy way for us to just not hard code that and just have it detect that it's on its final leg. Some kind of flag that if we don't move in each one of these, then it sets a flag, and then the flag, something like that. You know what I'm talking about. This guy is completely screwed up. What the hell happened? Okay, well, the wild true may not work, but that's debugging for the future, my friends. Thanks for watching. Go check out Farmer Was Replaced. Amazing game. Link in the description down below. I'll see you later. Bye-bye.